Recently, there was an unusual solar storm on the Sun, which formed a giant fire canyon. NASA's Solar Dynamics Observatory showed a vivid animation of this huge ejection of charged plasma. The solar wind reached Earth in April 2022, and on August the 9th, after a solar flare, charged particles bombarded our planet again. At 600 kilometers per second, they collided into Earth's magnetosphere, causing aurora. The northern lights were visible in the US states from Maine to New York. But scientists say this time we were just lucky. If a more powerful solar storm hit the Earth instead of a brilliant celestial show, it could have ended in a disaster. Solar storms have already shown their destructive power at least twice in the past. Now our Sun is once again nearing its maximum activity, and the likelihood of another powerful burst of plasma is increasing. How did these solar flares affect our planet in the past, and does the peak bar star's activity in 2020 threaten the Earth destruction? Solar wind is created when a stream of high-energy particles can no longer be held back by the Sun's gravity. Scientists think the solar winds blast from large dark spots on the star called coronal holes. The Sun is a huge distance from Earth, and yet coronal mass ejections can reach us in between 2 to 6 days. But the highest energy particles can overcome the same distance in just 2 minutes. Most of them are redirected to the poles by the planet's magnetic field, and only a small number of particles penetrate the atmosphere, emitting rays as they collide with gas molecules, causing the atoms to give off light. But sometimes the Sun starts having extremely powerful flares with the energy of about 10 to the 25 joules. That's roughly equal to millions of 100 megaton hydrogen bombs. During such a solar storm, plasma rushes through space twice as fast as usual. It bombards the magnetic field of planet Earth with such force that charged particles either pierce or significantly deform it. The result is the formations of geomagnetic storms, the strongest of which can lead to many disasters. On September 2nd, 1859, British astronomer Richard Carrington observed a giant solar flare. 18 hours later, one of the strongest geomagnetic storms we know of struck Earth on that day. Telegraphs in all of Europe and North America stopped working, and many telegraph poles were burned. People could see the northern lights almost all over the planet. Mankind recovered from the accident relatively quickly, but our civilization wasn't as dependent on electricity as it is now. When another major solar storm struck Earth in March 1989, the entire Canadian province of Quebec plunged into darkness, leaving millions of people without electricity for 12 hours. The solar outburst that caused this wasn't that powerful. If the next explosion on the Sun reaches the power of the current, an event the most intense geomagnetic storm in recorded history, it would be a catastrophe. In the past, scientists thought that the solar storms of this magnitude don't occur more often, and once a century, but then scientists from the University of Warwick and the British Antarctic Survey analyzed the patterns of solar flares. They discovered that powerful magnetic storms are much more frequent than previously thought. Solar activity has approximately an 11-year cycle at its peak. The Sun develops a particularly violent activity, and charged particles are directed towards the Earth, one after another. Researchers have analyzed the complete catalogue of changes of a magnetic field of the Earth. The results confirmed that the most significant bursts of geomagnetic activity coincided with the most powerful explosions on the Sun. the team of scientists identified two types of the most dangerous events for the Earth's strong magnetic superstorms and the strongest destructive megastorm. The former occur on average every 3 years. They affect the health of weather-dependent people, often causing headaches, blood pressure spikes, exacerbation of chronic diseases, but they don't lead to significant technical failures. Mega-strong storms are much rarer. Over 150 years, researchers have counted only 6 such events. So solar storms range on our planet about every 25 years, and over the past 2 decades there have been no megastorm. Scientists expect the next one to happen in the near future. A huge, potentially dangerous outburst occurred on the Sun in 2012, but the solar wind at that time blew the other way and hardly touched our planet during the next giant solar flare. We may be less fortunate. The exact consequences in such a scenario cannot yet be predicted. What we know for sure is that colorful auroras will be visible all over the planet. It's also possible that among them there'll be a special kind of a northern light called a strong thermal emission velocity enhancement, or STEVE, appearing as purple and less often white glowing ribbon. During the August 2022 geomagnetic storm, these auroras were observed even in southern Pennsylvania. Scientists don't know the exact nature of this optical phenomenon, but it's usually seen during solar storms. Researchers are confident that STEVE isn't just about the glowing show in the sky. It could be accompanied by the megastorm that will cause major disruptions to electronic and aviation equipment, communications, power grid disruptions, and issues with satellites. It could even reach the depths of the ocean, destroying underwater online communications cables. This would lead to a worldwide internet apocalypse that would last several months or more, according to some estimates. The damage could well amount to billions or even trillions of dollars. If solar winds of this power hit our planet in 2012, some countries probably wouldn't have fully recovered up to this date. Still, the absence of lights, computers, and televisions seems like a trifle compared to a majority of other possible effects like droughts, floods, earthquakes, and tsunamis. These natural disasters are often attributed to solar storms. Observations show the maximum frequency of earthquakes is observed in periods of high and fluctuating solar activity. It could have been one of the reasons for a magnitude 9.1 earthquake that happened in 2004. It also caused a huge tsunami in Indonesia, India, Thailand, Bangladesh, the Maldives Islands, Sri Lanka, and Somalia also suffered from this natural disaster. Over 283,000 people perished. Another 14,000 people are missing and more than 1 million are homeless. To mitigate the disastrous consequences of solar storms, scientists need to have a warning system. Several spacecraft, including the Solar and Heliospheric Observatory and the Solar Dynamics Observatory, are studying the Sun. Their data will help alert us about extreme events on the star in time now, as the Sun nears its 11-year peak of activity. This is especially important, and only once the stormy activity of the Sun goes down in 2024 can we breathe a sigh of relief, or can we? Recently, scientists found that a powerful geomagnetic storm is able to ignore the 11-year solar activity cycle and suddenly strike the Earth during the Sun's calm period. Scientists have again found a similar example in our past. A new study of ancient ice amples under Greenland and Antarctica has shown that 9,200 years ago, a solar storm of unprecedented strength hit our planet. so destructive solar storms can happen when we least expect them. To avoid being caught off guard, many governments have declared space weather forecasts to be a priority in the development of science. High hopes are pinned on NASA's Parker Solar Probe. The probe now travels closer to the Sun than any spacecraft did before. This means it can spot coronal emissions faster than any other spacecraft. Data from the Parker Solar Probe will help scientists more accurately track the region of a storm's formation on the Sun and possibly determine its direction. NASA and the European Space Agency also launched the Solar Orbiter probe in 2020. It's now traveling in an elliptical orbit with the closest point of 42 million kilometers from the Sun's surface. The probe has already sent incredible images of the star back to Earth. Some of them show many small bright spots and strange dark objects which are moving and vibrating. These are miniature plasma eruptions that scientists call campfires. Such phenomena probably raise the temperature of the stars. Corona and core solar winds, meanwhile. Other researchers are looking for ways to protect Earth from space. Recently, Japanese inventors from the National Institute for Fusion Science developed an artificial geomagnetic field project. According to geophysicists, the planet's own field has become about 10 feet thinner over the past 150 years. One day, it may not be able to withstand the outbursts of highly accelerated charged solar particles, scientists suggest, launching 12 superconducting rings around the Earth to protect it. Such a structure is thought to be able to enhance the geomagnetic field of the planet, but it can only compensate for the 10 that it's lost. But maybe we don't need to build any protective structures around the Earth as they're already there. NASA's space probes discovered a kind of artificial energy barrier around the planet, and it was formed by humans due to the interaction of very low-frequency radio waves with cosmic particles. The human-made barrier was found using Van Allen probes, which are designed to study electrons and ions in space around the Earth. Normally, very low-frequency signals from radio telescopes are transmitted from Earth and used to communicate with submarines deep in the ocean. According to NASA scientists, these signals formed what looks like a huge bubble of energy enveloping the Earth. Its outer layer extends almost exactly to the inner edge of the Van Allen radiation belts. These belts collect charged solar wind particles that later attacked the planet's magnetosphere. Researchers say that in the absence of bubbles, the radiation belt boundary would be much closer to Earth than it is now. In the 1960s, when low-frequency communications were less common, the inner boundary of the Van Allen radiation belt was at a much smaller distance from the planet's surface. Do you think this type of shield can protect us from the consequences of the most frightening solar storms, or should we consider other, more reliable ways to defend ourselves? Ancient people only knew as much about our sun as they could see with the naked eye. Today, we have telescopes and other technology that help us make better observations. But what if we could investigate our sun up close? Recently, scientists have designed and launched a probe on its first, in human history, journey to the sun. So how close did the spacecraft get? And why didn't it melt? Get ready to discover this and some other mysteries of our neighboring star. Without the sun, no life on Earth would be possible, but this gigantic ball of hot plasma can also threaten us. Its bursts of radiation, also known as solar flares, and its explosive ejections of plasma, called coronal mass ejections, accompanied by intense magnetic fields, can be frightening. Even though the sun's activity causes spectacular auroras on Earth, spacecraft, satellites, high-flying airplanes, and even astronauts can be in danger. Because of solar storms, our telecommunications, navigation systems, and power grids can fail to properly operate. We haven't been able to understand the sun and how it works, or when it's going to throw a massive ball of fiery plasma our way. This is why scientists have long dreamed of studying our star from a close distance. We know that the solar wind is a constant stream of charged particles that gains enough speed to escape the sun's outermost layer, the corona. But we don't know how energy and heat move through the corona and what accelerates solar energetic particles. Astronomers have been seeking the answers to these questions for 50 years, but to no avail. Finding answers meant sending a spacecraft through the corona that reaches about 1 million degrees Celsius, and it seemed impossible to accomplish until recently. This is what the Parker Solar Probe was made for, and it's truly a marvel of human technology. In 2018, NASA has successfully launched the Parker Solar Probe to revolutionize our understanding of the sun and space weather. The Parker Solar Probe was designed to become the first spacecraft to enter the sun's atmosphere. It's the size of a small car, and it weighs 685 kilograms. The spacecraft has several important instruments on board: the solar wind, electrons, alphas, and protons. Investigation or sweep will sample particles in the solar wind. The instrument has 4 sensors that calculate the abundance of particles. The Wide Field Imager for Solar Probe Plus, or WISPR, is a telescope that can take 3D images of our stars, corona, and any structures that pass by the probe. Another tool that Parker is equipped with is called Integrated Science Investigation of the Sun. It's made of 2 separate instruments, each having a different energy range. The instrument can weigh highly energetic heavy ions, electrons, and protons moving through the sun's atmosphere. Lastly, made of magnetometers and electric field antennas, the Parker Solar Probe will use electromagnetic fields investigation tool to analyze magnetic fields, radio emissions, and density of the sun's corona. But how can the Parker Solar Probe get so close to our star without melting? To study the sun under such extreme conditions, the probe and its instruments are equipped with a super reflective coating and a shield that measures 3 meters in diameter facing the sun. The shield, called the thermal protection system, is made of 5 centimeters of thick carbon composite. This makes the Parker Solar Probe capable of withstanding temperatures outside the spacecraft that reach roughly 1370 degrees Celsius, and even though that might not seem like enough protection, the density of the sun's corona isn't high, and not many particles actually hit the probe. The spacecraft and its instruments are also strategically placed in the center of the shadow that's coming from the shield. The Parker Solar Probe also has sensors to let it know that the heat shield has been adjusted when needed. Another level of protection is located on the inside of the probe. Parker has a dual array of solar panels and a smart cooling system. The cooling system circulates water behind the solar cells where it gets heated. Then this same water is pushed down into the radiators where it's cooled. All this makes the Parker probe resistant to heat and radiation like no other space probe before it. And even with that level of protection and low density of the corona, Parker can only stay in this layer of the sun for a few hours. But how in the world is it possible to even send a probe towards the sun? It's 150 million kilometers away and would take forever to get there. Reaching the sun isn't that simple. When a spacecraft is launched into space, whatever velocity rockets give, it will be superimposed on top of Earth's orbital velocity, meaning that we can either cause the spacecraft to have more or less orbital energy than the Earth does. We can either boost it to a higher, less tightly bound orbit with respect to the Sun, or debost it to a lower, more tightly bound orbit. Most of our space probe missions use planetary gravity to accelerate spacecraft and give them more orbital energy. But with Parker, scientists needed to do the opposite, make it lose orbital energy. The Parker Solar Probe has used multiple slingshot orbits using Earth, Mercury, and mostly Venus to enable it to get this close to the Sun. And each time it goes around the Sun, the probe picks up an insane amount of speed. Astronomers call it gravity assist, and it helps Parker narrow its orbit around the Sun and bring its perihelion about 4 kilometers closer. So did it actually touch the Sun? Unlike Earth and some other planets, the Sun doesn't have a solid surface, but it still has a boundary. The point where the Sun's gravity and its magnetic forces keep in the solar material is called the Alfvén critical surface. According to astronomers' calculations, it should be anywhere between 10 to 20 solar radii from the surface of the Sun, which is roughly 7 to 13. 8 million kilometers. And scientists believe that it marks our star's boundary with every gravitational maneuver. The spacecraft narrowed its distance to the Sun, and as it did so, astronomers searched for sign. The Parker Solar Probe had reached the critical surface. So what happened when NASA spacecraft arrived at its destination? As the probe passed through a pseudo-streamer, or a loop-like structure in the corona of the star, the whirlwind of particles started moving much slower, limiting the impact on the probe. This meant that the magnetic fields were dominant in that region so that no particles could escape it. It was the proof that the Parker was inside the Alfvén critical surface. The spacecraft then recorded a video of coronal streamers moving past it. It was the first time scientists were able to see these mysterious objects from up close. The data collected from the probe shows that switchbacks, or zigzag structures in the solar wind, are quite abundant close to our star. Before, astronomers thought these zigzag structures were rather an abnormality, occurring near the Sun's poles only. But the spacecraft helped scientists conclude that these structures originate in the solar surface and are quite common. Parker has also discovered that the critical surface was 8 solar radii from the solar surface, and it took 8 flybys and over 3 years to finally get there. But this wasn't the only discovery made by Parker that fascinated scientists. Multiple flybys near Venus have opened more opportunities to study this hot world. Until recently, astronomers didn't know exactly what the planet's surface looked like. Usually, it's covered with thick clouds, so a big part of the visible light coming from the surface of Venus is shrouded from sight. Parker didn't only manage to record the atmosphere of our Sun, but it also captured Venus's surface from space. During its flybys, Parker used its wide-field camera to take images of the entire night side in wavelengths of the visible spectrum. For the first time, scientists were seeing Venus's surface in visible wavelengths from space, even on the night side. The surface of the planet is roughly 475 degrees Celsius. It's so hot that you could see its rocky surface glowing. So far, the spacecraft has approached the Sun at a distance of 5 million kilometers from its surface. The previous record was set by the Helios 2 spacecraft in 1976, and the distance was only about 43. 5 million kilometers. Aside from that, Parker is also breaking faced speed records. During one of its approaches, it was moving at about 700,000 kilometers per hour. At that speed, it would take Parker about 1 second to get from Philadelphia to Washington, D.C., or less than a minute from New York to Toyo. This makes it the fastest human object ever made. Scientists haven't found answers to all their questions yet, but as the spacecraft enters the Sun's atmosphere again and again, we'll find more clues. The Sun has an 11-year activity cycle during which its stormy behavior intensifies and then settles back down to a minimum, and because it currently ramps up, its corona will expand, giving the Parker probe even more opportunities to enter it again and stay in there for a bit longer. Eventually, the spacecraft will get as close as 1 million kilometers from the Sun's surface. This is just within the orbit of Mercury, which is roughly 7 times closer than any spacecraft has ever approached the Sun. Before, the Parker Solar Probe hasn't finished its mission yet. NASA wants to send the spacecraft deeper into the solar atmosphere to collect more data about how our neighboring star works. It'll help better understand the phenomena happening inside and around the Sun. The Sun is the only star we can study from such a close distance, and the only one known to us that can support life. So if we understand it well enough, we can succeed at searching for life outside our solar system. Eventually, the probe and its instruments will start failing, and the spacecraft will melt into a charred piece of metal that'll keep orbiting the big glowing ball of hot plasma. Its journey will come to an end, but until then, it could surprise us with more fascinating discoveries. So stay tuned, as we'll make sure to tell you everything about that.